and gentlemen, welcome to the first of hopefully a couple of journeys into space. Tonight we're going to be vibing out in the planetarium a little bit here. Just get this going here. Perfect. All right, guys. I think we're good to go. So we just started on some random planet here. You can see clearly has a nice close star right there. Seems to have a neighboring planet, some kind of gas giant, almost Jupiter-esque. Let's go take a look at that. Oh wow, there's some very interesting little galaxies or nebulae out here. I think we could increase the speed of time as well. Oh, let's turn that off. Just gonna bring this up over here. Alright, let's do some flying. So we're gonna zoom away from these planets and increase our speed. And as we leave this little subsystem here, this little solar system, it's just descending deeper and deeper into space. It's a beautiful little system here of planets and stars. Seems to be a couple. Let's check out this guy. Almost too fast there. This is a white main sequence star. I think we can almost land on the surface of it without getting too fucked up. Now, let's flip back to Earth real quick. We're going to start our home system. There we go. Not too far away from where we just were. All of us are pretty familiar with this beautiful little guy. I'm just going to zoom out a little bit. Sort of fly away from our blue dot. And see that little tiny speck? Just gets smaller and smaller. Our sun. And we're just gonna peace out. As we increase our speed, you're gonna see the sun getting slowly smaller and colder. And then you'll see other systems with suns of their own, planets of their own. We're just gonna increase our velocity. Now, just for some perspective, we are moving at 20 light years a second right now, which is an astronomical speed. And I mean, like you see these galaxies over there, they're barely even moving. We are going to start to increase our speed though, and actually pull ourselves out even further away from Earth. And now remember, it's right about here. As we pull out of the Milky Way, there's our giant galaxy, and we're just this tiny little dot in this massive cluster. And just to give you some perspective on how big this cluster is of stars, as we pan around and we see these other nebulae or galaxies of their own, right? Whoops, sorry. Got a little excited there. Yeah, these are... too fast, too fast. There we go, that's better. Sorry guys, controls are a little janky sometimes. Now these are... yeah, galaxies of their own, filled with stars, planets. But let's just go back to the Milky Way really quickly. We're gonna fly kind of center mass through it and check out the center. I'm gonna slow things down a little bit so you guys appreciate it. And every little speck of light is a star with its own set of planets. There's millions of them. Billions, trillions. And as we get further into the cloud here, you can see the density start to increase. As we approach sort of the center. And then you can start to see some of these super clusters of large stars. Absolutely beautiful. And this is kind of what makes up the center of the Milky Way. These incredibly large, dense clusters of large stars. Now let's pull out of our beautiful galaxy here. I just have a little bit of appreciation for the scale of space right now. All of those specks are galaxies, or clusters of huge galaxies. And as we pull out from the Milky Way, I hope you get a little bit of perspective for just how insane. Like, remember, we are a tiny little speck on the outer rim of this thing. And here we go. You know, that's our guy floating in space. Not really floating. It's actually traveling with a velocity in a direction. And then the star field just kind of starts to lose its way. I'm going to go a little deeper here, guys. It's endless. You could fly around for eons and just find these super bright objects out here and hone in on them and say, okay, I'm curious what this is. Out of all of these stars, what here is burning oh so bright? What beautiful object is this? It seems to be quite the bright center of the galaxy here. Wow, 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 wow. Okay, this is kind of insane. Wow. Thank goodness we have a good graphics card. Oh. Whoa, I crashed Space Engine. Sick, guys. That's fun. That's a new one for me. All right. Well, you know, let's see if we can get it back up and running here. I really wanted to show off the Crab Nebula. It's another fascinating one that's fun to fly through. Let's bring it up here, guys. The Crab Nebula is in our galaxy. How do I change? Oh, the equatorial grid. Sick. That's kind of cool. Sorry guys, I just really want to try and find the setting for how... Okay. Let's turn this grid off. So this is the Crab Nebula. It's comprised of a variety of different gases, such as hydrogen, nitrogen, others that I should probably look up. Let's actually do that right now real quick while we're checking this out. Crab Nebula. It's a supernova. Oh, that's a remnant of a pulsar. A wind nebula in the constellation Taurus. The common name comes from blah, 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 blah. What is the Crab Nebula made of? So, what is its physical parameters? So, visible light, Crab Nebula contains a broadly oval-shaped mass of filaments about 6 arc minutes long and 4 arc minutes wide. Blue region, 3 dimensions. It was thought to be shaped like an Okay, here we go. So, the filaments are remnants of the progenitor star's atmosphere and consist largely of ionized helium, hydrogen, along with carbon, oxygen, nitrogen, iron, neon, and sulfur. The filaments' temperatures are typically between, that's hot, and the densities are about blah, blah, blah. Interesting. Okay, so that's what actually composes this particular nebula, and like it says in the article, it actually came from, why am I stuck? Sorry. That's fine. It's very encumbered. Sorry guys, it came from a supernova. So a star exploded and created this giant, dust cloud in space. Let's see if we can find the pillars of creation. There we go, in the Milky Way. Now, these are all, again, like in our local area, and they're cool things that we have found through radio telescopes, X-ray telescopes. One of the interesting things about space and the way that we see it is we don't just look at the light. That is definitely one thing. We build these extremely large telescopes so that we can capture as much light from a distant place as possible. But we can also use other things other than just visible light. We can use things like X-rays, infrared, and a variety of different spectrums of the electromagnetic spectrum. And that allows us to visualize things in different things like infrared, ultraviolet. And that's why when you see the pillars of creation here are probably being visualized in their current, like actually how you would see them if you looked at them. And red typically denotes hydrogen. So let's take a look and see these guys. See, that's what NASA took a picture of, right? So, cosmic dust and gas, the Eagle Nebula, pillars of creation on the stunning Hubble image. Well, it's not Hubble's first image of this iconic feature. The Eagle Nebula is the most detailed. The blue colors in the image represent oxygen, red is sulfur, and green represents both nitrogen and hydrogen. The pillars are bathed in the scorching ultraviolet light from a cluster of young stars located just outside the frame. The wind from these stars are slowly eroding the towers of gas and dust. That's pretty cool, guys. It's amazing. This is what's going on in space right now. This is, the pillars of creation. It's too bad we don't have anyone in the chat tonight. I would love to take suggestions from people of things that they want to see. We might be able to find a quasar if we look it up here. Quasars are another interesting... let's look up. Where are quasars? So. Cool. See if we can find this one. So what is a quasar? A quasar is known as a quasi-stellar object, abbreviated QSO, is an extremely luminous active galactic nucleus which has a supermassive black hole with a mass ranging from millions of billions of times the sun and surrounded by a gaseous disk. So what's interesting about quasars is, unlike regular galaxies, they actually emit radio waves, and that's how we first picked up on them. We're like, what the hell is this weird super bright object that is also emitting X-rays and radio waves from it? So I wonder if is this available to us? Can we find this guy? Oh wow, the formatting is unfortunate here, eh? Let's just try this. PG 1302. Oh, okay. Let's try HE04. No. Let's see what's out here. Close enough, right? Oh wow. Got ourselves a big boy. So you can see, unlike the Milky Way, this one has an absolutely massive, bright core to it. And, you know, if we decide to, like, let's find a little arm of this where something like an Earth might be. You've got this, incredible dark mass that starts to reveal itself with all these tiny little dots. And if we just pick one out of the air, we can zoom in on it. And let's go see what's going on there. So this is star RS-139. It's a yellow giant. It's a binary star. Whoops. And, oh, a binary. Cool. It's a fascinating object. There's two of them. Binary stars are when you have two large masses that are orbiting each other. And they have a stable orbit, almost like a cohesive orbit in which they're, you know, not causing any issues. Pulsars are kind of similar to binary stars in a way. But isn't that beautiful? It's amazing how you just see these truly bizarre pairings of... Oh, thanks. Appreciate it. I hope people love Space Engine. It's a cool platform. If there's anything you want to look at in space, I got you. We're starting regular travels into the darkness together to try and find some light. Oh wow, cool little system here. All right, let's explore. What do we got? So it's a yellow giant. It clearly has a couple of planets orbiting it. What we know from typical orbits is that there is like a Goldilocks zone in which a planet needs to be a certain distance from it in order for it to host life. I don't know what that radius is or have any scientific proof to back it up, but some of these guys look kind of close and they might be just a little too hot. But let's zoom in and take a look at what these look like, because these could be planets with their own moons. So this is a scorched ice giant. Scorched ice? Never heard that term before. That's kind of cool. Let's take a look. Like, just imagine living in this part of the universe, you know, or being able to traverse at these speeds and see these incredibly odd stellar objects that we just don't have any like exposure or perspective for, but they exist. You can see this stuff. Whether it's using, again, telescopes or so here we got ourselves a beautiful little planet. scorched ice giant, as they say. It looks like it has some asteroids just hanging out around it, scorched asteroids. I don't know if they'd call these moons or not. But it involves AU. Okay, AU is I'm slightly AU is either has to do with the distance between like Earth and the Sun, or it is a function of the speed of light. So what is AU in astronomy? Here we go. It's an astronomical unit. It's the symbol AU, or unit of length, roughly the distance. Okay, from Earth. My memory wasn't that bad. From Earth to the Sun. So like, you find this in physics and science a lot. We have these like really weird arbitrary things that sort of make us as the center position. So when you look at something and you click on this planet and you're like, okay, you know, what is the size or the diameter, right? It gives you into kilometers. But if I was to click on a star, right, it might actually give me the diameter in AU because it's such a large object. It's an interesting unit of measure for astronomers to use. For example, if we're traveling, you can see that I'm moving 14 or 23 AU per second. So that's the distance between us and the sun per second, which, again, is 150 million kilometers. Like, they're numbers that are almost impossible to really visualize. I'd love to find life. But what I think is interesting, too, about finding life in the universe is we don't know... Oh, yeah, tell me. It could just look so different. Could look so different from what we're used to or what we're expecting. I love when the star field just comes into view. It'd be super cool. It's a button with lots of dots on the right. This one? Markers enabled. Oh, this one. No, that's stars. Oh, on the left. Star browser. Universe map. Oh, wow. This is kind of cool. Holy shit. Pardon my French. That's amazing. So what's this guy here? This is... That doesn't seem to do anything. That brings up our star browser. This... blah, blah, blah. This is just our journey log. Locations. Display settings. There we go. Oh shit, time. I forgot to turn on time. I love time. Star browser. Search. Yeah, I'm still still trying to figure out the ropes. I'm sure I'll find it. I'll find us a video at some point and figure out how to pull up life. Okay, this has caught my fancy. Oh, okay, I see. So you're saying you can put a bunch of parameters in here, and one of them there is it. Oh, life. Okay. Search radius for... I don't understand why it won't let me... Enter filter settings. Oh, okay, okay. Systems may start any object turns on mass temperature or organic life. Yeah. Let's say it has multicellular life, exotic life. Multicellular would be sick. Let's apply those. Search? Oh, actually, like 100 light years, probably. Yeah, so I see here, so... Yeah, we'll do any biome. Actually, let's say just organic life doesn't matter. Search. Now, well. I'll look up a tutorial later. It's just so crazy that, like, we'll never have the capability to travel at these speeds. And another thing that people forget about, that's kind of fascinating about space, is that, like, these objects, they're literally, that's what we're looking for here. They are, they're flying away from each other. Like, space is slowly flying apart, right? And so as a result, like, you know, unless there is some way to break the light barrier in terms of travel, there are some parts of space that will just be forever unable to connect with one another as a nature of its fabric ever expanding. Because that's one of the fascinating things about space, is it's not only... Oh, I think we crashed it, guys. I think we crashed it. Yeah, crashed it. Not only is space expanding, but the rate in which it is expanding is increasing, which is weird. It's something we don't fully understand yet, but we've got some interesting ideas about why it might be happening. I love turning on time. It just makes everything so much more elegant when you can see the dance that the planets do, you know what I mean? Oh, for sure. It's just part of the journey. Crashing space engine is, if you haven't crashed it, you haven't used it long enough then. But it's so interesting just to watch these little objects, you know, do their dance, hurtling through space, composed of all kinds of interesting matter that was synthesized in large stars that one day explode and expel their refined materials. One of the reasons why we have things like uranium and lead and carbon. Carbon isn't something that's just like floating out in the universe. The universe is like mostly hydrogen and then a couple of other very small amounts of different atoms. But suns or stars, when they get super dense and all this matter condenses into one point, the fission of that is able to fuse together and create all kinds of cool elements. And it's in those furnaces, it's in those giant like fission machines where all kinds of cool materials that we rely on every day are made, you know. They're not joking when they say you're made of stardust. Like, the carbon in your body literally came from an exploding star. That's sick, guys. Neil deGrasse Tyson's a huge fan of that fact. So here we got ourselves a little cluster. I'm gonna explore this cluster for a little bit, see what's up. Again, all of these are just tiny little specks of light, but they're gigantic stars. Like, you got orange giants, you got yellow giants, you got white dwarfs, orange dwarfs. We're going to zoom in on one of them just to give you some perspective, the scale of these things. Oh, look at this cute little orange dwarf here hanging out. Such a cute little guy. Is that a binary? Holy shit, it's a binary. Okay, that's cool. It's an orange and a red dwarf binary combination. And again, if we can turn on time. Look at this. Again, just these beautiful little things, man, doing the little dances through space. While we worry about, you know, whatever it is that we worry about. But it's incredible. It's the universe is so full of magic and wonder. You know, you gotta ask yourself, there's gotta be something cool out there waiting for us, you know. And if there isn't, well, then, you know, maybe we have a responsibility to make sure what we've got is really special. We take good care of it. And when you look at yourself as this human, this carbon-based life form spinning on this globe, you know, just think about how big you are, maybe just a little bit how small you are too. And tonight is a good way to just zoom out and leave our first space exploration. There we go, we just fade into the dither. This tiny little speck on the outer rim of this truly insignificant galaxy, really. It's not special, there's nothing particularly different about it. We're just hanging out on this calm, quiet little edge where life was able to self-organize. It's really fun to hang out, guys, and talk about space, and I hope as we spend some time hanging out, you guys enjoy yourselves, you take care of yourselves, and keep looking at the stars, guys. Keep thinking about what's waiting for us out there and down here too. guys. Thanks for coming and hanging out tonight. Appreciate you spending time with me, exploring the universe. Take care of yourselves. Come say hello again. Everyone is welcome. It's always cool to hang. Be well, and take care. All right, ladies and gentlemen, we are back. Attempted to reduce the quality for you, my friend. Hopefully that makes a difference. It's the best I can do right now. But always want to try and make space more accessible and fun for everybody. Alright, here we go, guys. Let's see if we can find Planet Cold Titan. Some other random thing. Oh, wow. Okay. I'm trying out the free version before I get the Steam version. We'll see if I can get more people on the stream, and then I'll upgrade accordingly. Alright, so what are we looking at here? We're looking at a blue giant. Wow, this is a bright star, guys. Jeez. Look at it. Oh, shit. It's a binary cluster. Look at, and you can see the auras of the magnetospheres. This is fascinating. All right, cool. Let's turn up time a little bit and see what happens. Okay, that's a little epileptic. We're going to tune it back. But holy crap, that's cool. Oh. Bonjour, mon ami. Comment ça va? Je m'appelle the son of Moog. Je parle un petit peu français. Je live in Canada, so I learned a little bit of French here and there. That's about as good as it's gonna get, so I hope you enjoyed that. That's... Alright, let's, there's... Oh, right. Hold on, before we get... Oh, whoa, where did this nebula come from? What is this? Okay. We got a couple things. First off, one of the objectives of the stream is to learn more about space. So what is a blue giant? Blue giant star. Alright, so let's check this out. Blue giant. From the wiki... So, in astronomy, a blue giant is a hot star with a luminosity class of 3, giant or bright giant. The standard Hertzsprung-Russell diagram, these stars lie above to the right of the main sequence. The term applies to a variety of stars in different phases or development. All stars that have moved from the main sequence but have little else in common. So, blue giant simply refers to a star in a particular of the HR diagram rather than to a specific... Interesting. Okay, so... The name of the blue giant comes because it is misapplied to other high-mass luminous stars, such as sequence stars. Ah, interesting. It's a little sketchy. So it does, I'm sure, come from the fact that they are blue, but it has more to do with where they are in their scale of the life cycle of how a star is born. No, I did not know that. I'm sure it's pretty cool for creating cinematics. Like, it is a beautiful application. I'm hoping that my number one buddy, Juju, gets to take a look at this. He's my nephew, and gets to explore space and can show him some cool stuff as we float through and explore the galaxy together. Gotta love there's some interesting stuff going on in here. What do we got? A binary, a Wolf Riot star. What do we got over here? So we got some clusters. Oh, it's a whole star cluster. Let's go check that out. There might be some more interesting stuff over here. I'm sure you could create some really cool. So a white main sequence star. It's just a bunch of white main sequence star, which makes sense. You would see, you know, a lot of similar stellar objects popping up next to each other based off of, you know, the content of materials in that particular region of space. Ah, this is a glob. Let's check out this globular galaxy out here. Oh, here we go. So this is, yeah, one of these globular clusters of stars. Which, to an extent, we make sense because depending on how something exploded at some point, you know, during the evolution of all of these objects, but not just that, the gravity alone of these things pulling each other together and attracting each other to one another must be phenomenal. So again, you're going to see a lot of supergiants, a lot of yellow giants. Let's look at a yellow giant here. So yellow giant stars were all main sequence stars once. Typically stars that have between 8 and 12 solar masses spent only a few million years on the main sequence as O-type stars, where they cool and expand greatly into a yellow giant. As their okay, so yellow giant. Really quickly, we're going to talk about what stars are and how they form. So stars are giant fission reactors. That's not to be confused with fusion, which is what we have in nuclear power plants. This is fission. This is the forming of atoms. And as fission occurs in a star, the fuel that is fusing together turns into elements like helium and all kinds of other fun stuff. And as that is expelled, what's left inside of the star becomes this like very dense core of stuff. And as the star gets old and it runs out of steam, essentially, it expands. It actually swells up before it caves in on itself and explodes. So it's a very interesting life cycle that stars have as they, float through the universe, and they all grow up and get old and die, just like us guys. Stars are just like us. They might stick around a lot longer, kind of like a tree, but not forever. Wow, what an interesting galaxy this is. Wow, what is this? It's a nebula. So as I'm sure you guys know, nebulas are collections of gas that form. Again, gravity brings this stuff together and allows it to collect, but that doesn't account for dark matter. And I think that's a subject for another night if you guys are interested in liking the channel and favoriting up so you can see when we're coming online and talking about fun stuff. Dark matter is going to be next on the subject list as we explore. I think what we're going to get ready to do here is, I don't think it's as easy to find. Okay, let's see if we can find one here real quick. Alright, here we go. Oh wow, here we go, guys. Black hole incoming. Here we go. Get ready, it's coming. Holy shit, this is insane. And we're going to blow through it. We are if we're not careful. Okay, we missed it. It's somewhere here. Oh, I feel like I'm right on the cusp of finding it. I can see the poles of it. Be able to zoom in on it. This is crazy. Oh wow, here we go. Gotta be. Oh, I think I. Oh, wow. It's like. Is it so big that I just can't see it? Is that really what's happening there? That's wild. Well, I appreciate you coming to say hello and staying as long as you can. Don't feel obligated to stay longer than you need to. We're going to be back a couple nights a week doing this sort of thing. So come by anytime. Drop in or out. We're not going anywhere. And thanks for saying hello, mon ami. Bonne nuit. Au revoir, à bientôt, and take care. I think this is a good time for me to sign off anyway. It's been a long day. Respect, I appreciate that. Thanks, bud. Respect. Have a good night. Take it easy and be well.